Hey guys, can you hear me? Okay,
Yes.
good. All right, sorry for the delay. I've had a series of crazy things going on. So
Understandable.
on campus today is related to the issues I was having before in class, if you remember. And so
Yep.
I don't want to drive just yet, and kind of go from there. Um, okay, so let me get turned on. All right. Good. All right, I can see you. You can see me here. Pull up this, and I want to share my screen. All right, you should be able to see a PowerPoint presentation.
Yes.
I almost never do, but we're going to work on a problem through it. Okay. Can you see it?
I can see it, sir.
Okay. All right. You can just nod your heads. I'm on one side of the screen. I got all your pictures so that I can see what's going on and get visual cues from you, which is pretty helpful. Okay. So I want to talk about, and this is where we're going to start talking about how to apply the math that we have come to acquire. And I don't even like the way they do math in this presentation because it doesn't give you, they do the calculations to get the right answer, but they don't explain to you how you get the right answers or how you know how to calculate it. So this presentation is downloaded to Canvas, so you can get it from there and you get the answers. And I'm going to want you to work on this as we're moving forward. But today we're going to talk about the definitions of various terms that you have to know in operations management. Okay. And so I don't want to do those two. Come on down. Capacity. Really important term. Capacity is the number of widgets that your company, to boil it down, is the number of widgets your company can make or produce in a period of time. It's a really important number because it also helps you figure out what your costs are and to determine if you are able to meet the demand of your customers. Forget that one. Okay. There are two types of capacity, and they're both really important to know. There's a design capacity, which I call theoretical capacity. It's the maximum amount of throughput you can get out of your company if you had to push things all out. It's a number that you never really obtain. Effective capacity is the number that you can put through the company on an average day with normal conditions running. And there are constraints to that. And those constraints are based upon simple things. For instance, if I'm running a machine line out there, a production line, there's a limit to the amount of time that that line can run without needing maintenance. It needs to go down for a period of time. We need to run maintenance on it. And during maintenance, we don't have production going on. If I'm running multiple shifts, there is some period of time in the changeover of shifts that I don't have production running because the workers are changing out. So the whole thing comes to a stop for some period of time. And so you lose that degree of effectiveness or capability of producing product. You're not going to be able to produce that design capacity. You're going to be coming up with this thing called effective capacity. So you got maintenance that would be on those constraints. It might be your supply chain may not be able to allow you to do more. Maybe you only have enough inventory going on that allows you to, or in-house, only run at a certain rate. And so if we are running just-in-time inventories without adjusting those inventories coming in, you're going to run out of product if you try to crank things up above what you projected going forward. It's always lower. The effective capacity is always lower than the design capacity. Let me stress that. It has to be, effective capacity must, and they say often lower, it must be lower than the design capacity. Design capacity, and if you're comparing apples for apples in units, like we talked about, then you can do a direct comparison and we can work through this. And we're going to do a problem in class today related to this. Yeah, so we just talked about that. I'm not going to go do that again. So I hate slides. I get to talking and I don't care what they're. So they're giving you an example. Frito-Lay loses 3 hours of output per day for preventative maintenance, for employee breaks, and to set up products for different. Set up lines for different products. And that is a loss that you will have. Oftentimes, if you have the same product being made or different products being made on the same line, you have a changeover that must occur. And that takes some amount of time in order to do that. If you're working on that. So yeah, guys, I've got construction going on here at the house. So if you hear weird noises and all going on, just ignore that. I'll try to keep it to a minimum. Okay. All right. So a couple other terms that you've got going on are utilization, and it's a percentage of the capacity actually achieved, the design capacity actually achieved. So let's kind of talk about that. So you have the actual output that you got. Let's say you made 100 widgets yesterday, but your plant has a design capacity, a theoretical capacity of 200 units. Your utilization is going to be 50%. Does that make sense? Let me go back to that again. It's your actual output. And let's say yesterday you made 100 widgets, but your theoretical production capacity, your design capacity, is 200 units. So your utilization is 50%. When you divide 100 by 200, it'll be 50, and that's 50% when you're doing this. Are we good? Everybody got that? Not a different thing. You need to memorize these definitions. You will see them again. That's why I'm doing this way. Efficiency is the percent of effective capacity actually achieved. Now, somebody tell me, we just talked about effective capacity. What is effective capacity again? Someone want to venture out?
Capacity that the firm expects to achieve during a given period of time.
Yeah, with the constraints subtracted from that number. So this effective capacity right here, let's say your effective capacity is 175 units a day. We're just talking about where your design capacity is 200, your effective capacity, you've calculated it to be 175. And if you're producing 100, it'll be 100 divided by 175. You simply divide it out. Very simple. And they're unitless numbers. And we'll get to that in a minute. And it makes it confusing because you've got efficiency, you've got capacity, you've got design capacity, you've got effective capacity. It gets confusing which one we're talking about if you're not careful on this. This is critical to understand this because you use these numbers to manage your business and to make investment decisions. So here's our problem we want to work on. Okay, so the actual production this week, when they're making rolls of toilet paper, I don't know, rolls of something. Actual production was 148 rolls. Our effective capacity is 175 rolls. Design capacity was 1,200 rolls per hour. Oh, it's a bakery. Bakery rolls. Oh, wrong type of rolls, guys. So I was thinking toilet paper rolls here. Yeah, bakery right at the top. What am I thinking? They're running 7 days a week, 3 8-hour shifts. All right. The problem with the data you're given is that the data isn't in all the same types of units. You've got rolls per hour, you've got days per week and shifts. So let's see if we can get a common number that works together here. And this company looks like they are basing their production capacities off of weeks, just based on the units that they're providing us. They could have done it in days. They could do it in months. You could do it in quarters. It doesn't matter as long as all the numbers you're using are the same units. This is why that previous segment we did on unit analysis is so important, because now we're tackling units. And if you go in and say, oh, it's 1,200 per hour, but the effective capacity is 175,000, how can that be? 175,000 is bigger than the design capacity, and Dr. Bailey already told me that design capacity must be bigger than effective capacity. So something's wrong. So the question is, how do you get design capacity to look like effective capacity over a week?
I think we figure out how many hours we have in the week, times the amount of rolls we can make per hour to figure out our maximum output.
Right. Okay. So let's do this. So you've got 1,200 rolls per hour. Somebody get on their calculator. So what do we want our answer to look like here? What should our answer look like? In units, not the answer. What should the units be?
Weeks in weeks.
Rolls per week, right?
Rolls per week, yeah.
Rolls per week.
Yeah,
Okay.
I've got 201,600, and it should be bigger than our effective capacity.
And it is. Okay. So it's 201,000. So let's go back. Let's think about how we got there. You had rolls per hour, 1,200, and we want to get it into a weekly format. There's 7 days per week. So you're going to go 24 hours times 7 days, because there's 24 hours in 1 day, times 7 days per week. Now we got the per week down there, and that's all you need, because you know you're running on a 24-hour schedule. The extra information provided here, the 3 8-hour shifts, is extra information. You don't need it for this calculation. You just need to know how many hours there are in a week in order to convert this. Okay, some of you are looking perplexed. Did I lose you?
Why are we going off of 24 hours instead of 8 hours?
Because we're trying to convert it to the amount of production in 1 week, the number of rolls in 1 week.
And if you look at the 8-hour shifts, there's 3 of those in a day. So 3
Right,
times
that's
8.
24-hour shifts. But no other place on here talks about shifts yet. And this is how it works when you're a production manager. They give you a lot of numbers, and you have to sift through those numbers to get the information you need. Okay? So in this case, design capacity is 1,200 rolls per hour, but we want to know how many rolls per week. And we know we're running 24 hours a day. So it'll be 1,200 times 24 times 7. Make sense? And you
It does, sir. I do have a question, though.
cancel out.
Let's say that it said only 2 8-hour shifts were we could do because of the amount of employees that we actually had.
Right.
Would that affect the design capacity? Would that bring it down to just
No,
the,
but you could add a third shift. So your design capacity still could be 1,200 or 210,000, but your effective capacity would be reduced because you're only running 2 shifts.
okay. So that'd be a question of effective capacity, not design capacity.
Right.
Just the amount of employees here.
Now it would be a design capacity issue if, I had this at a company that I worked at. We use third shift to do all of our maintenance on the plant. So if all production is shut down in third shift so we can do maintenance, your design capacity is still the 210,000, but your effective capacity is reduced by that one whole shift. Because that's a constraint. The constraint has to include maintenance and breaks and requirements of law and training and everything else you have to do that would take away from actual production time.
So the design capacity would be 1,200 times 24 times 7.
Right. So if you put in 1,200 rolls per hour, so rolls on the top, underscore 1 hour, or underline 1 hour, multiply that, move the hours to the top of the next one. There are 24 hours in 7 days. And times, move days to the top of the next one. And it's 7 days over 1 week. So now everything cancels out and you are down to rolls per week. Yes? We good here or we lost? Because if you try to do it the way and you have the ability to look at these slides, they walk you through this, but they don't teach you this other way to do it. They just say pull an arrow from this data and you're multiplying this and you're adding that, and it makes no sense. There's no system for doing the calculations. And so by using dimensional analysis, you can make these calculations and you don't have to memorize the formula. You do have to know what the definitions are. Right? Okay, so what did we say utilization was?
The percent of design, actual divided by design.
Right. So we now know that we have a capacity of 210,000 rolls per hour, and we're at, or per week, and we actually produced 148 rolls, 148,000 rolls. So notice that this is going to be units. It's rolls over rolls, which means that it's unitless, which is almost always a percentage. So you're going to divide 148,000 by 210,000, and you're going to get a number. Somebody do that.
Got 73%.
73.
73.4.
Okay. Very simple. If you know what they go into, so if you know the definition, you can say, oh, I need to use this and this. But you do all your conversions up front so that you convert everything to the same unit, so you can just plug them in down below. It gets simple if you do that. If you don't do the conversions first, up at the top of this example, you're going to get into trouble. I promise you. So you've got to go through and convert everything so that they're in similar units. You can't have some things in units produced per shift, or units produced per hour, or just units. You know, you need to get them so that you understand that they're all the same, they're measuring the same thing. You're comparing apples and apples. Make sense? Okay. So what's effective capacity?
Actual output divided by effective capacity.
Right. Okay. So we can calculate that. What's the utilization then?
It's percentage of design capacity that we actually achieved during the given time.
Percentage of, go back.
Design capacity actually achieved.
Right. So effective capacity is the capacity a firm expects to achieve with operational constraints. Come on down. Did I not give you that definition? Yeah. Utilization is the percent design of capacity, design capacity actually achieved. Efficiency is the percent of effective capacity actually achieved. Actual output over effective. You have to know the difference between these two. The first, utilization, is primarily used for finance in the company. So when I go to justify I need to put in another line, or I need to upgrade a line, they're going to ask me for what's the utilization number going to be, what percentage. And I have to be able to tell them that, because they're going to calculate profits based upon it. As a production manager, I'm most concerned about efficiency. What's the effective capacity is really my limit as production manager. You can't cut corners on the constraints. You can put off maintenance, but generally you have a degradation of production if you put off maintenance or complete stoppages. And so it's not something you can do very long. And so I'm most concerned about the actual output versus effective capacity. How close can I get to that number? I want that number to be 99.9%. Can't usually get there, but I can generally get it into the 90s. On a good day. On a bad day, I hope I get over 50. Okay. You have to be able to do a problem just like this. This is chapter 7 in the book, by the way. I meant to say that. You need to read that chapter. Units, 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 units. If you can't do those units, you're going to get crushed. So I can't stress that enough. So here's an example of how you would use utilization efficiency to justify financial investment in the company. So expected output of a new line would be 130,000 rolls. Now that's the output. What number would that be? Is that effective capacity? Is that design capacity? What is it?
It's effective.
The effective capacity. What would be the new effective capacity for your company?
Goodness. What 175,000 plus 130,000.
Right.
So it'd be
So you'd be 305,000. Is that right? Yeah.
Yeah.
Yeah, 305,000 would be your new effective capacity. That's what we'd be expecting to do. Now,
What did we add to get the effective capacity?
so you have to know what number, the information they're giving. They say the expected output of a new line. Okay. Well, what does expected output mean? That's not design capacity, that's effective capacity. So you'd have two effective capacities that you could add together. So let's talk about where this number comes from. The company has gone out and said, we've exceeded our capacity based upon what? What would drive a company to say, I need to invest in a new machine?
I think demand.
Demand, right. Demand is generally the reason for it. Now, there are other reasons you could do it. If your equipment up here is 100 years old, or 20 years old, or in some cases even just 5 years old, you may be having enough breakdowns that you need to replace the equipment. And you're saying, oh, 130,000 rolls might be a better fit for us, and we can still keep the old line running for additional capacity. If you're buying new equipment, you're actually expecting to buy equipment that is more efficient than the ones you already have. They should be able to run faster. They should be able to take up less room. They should be able to use less electricity, maybe more automation. All of those things apply to you as you're moving through the system. Does that make sense? You're making decisions. You're helping people who are investing oftentimes not only tens of thousands of dollars, but hundreds of thousands of dollars to determine what's the right fit for the company. So if you build too small, if you invest too small, you get a bump in capacity, but you run out again pretty quickly, and you have to go through this process again. That's inefficient. Okay, but you don't want to plan for the world. You want something that's within reasonable numbers. Planning for growth. So you would look at your sales growth over the last, okay, so 5 years maybe, or 3 years, and the number of new customers, the number of new sales, and say, oh, we want to project out 5 years. And the further you get away from today, the less accurate your numbers become, but you're projecting those. And you'll say, okay, that will meet our demand for the next 5 years. That's an effective use of your capacity. Your CFO wants you running at 100% of capacity, effective capacity. Why? What's he concerned about?
Like higher efficiency means more money.
Means more money, more cash flow for the company. Okay, you have to, if you have times when you have to shut down both lines. You don't have any money coming in, and you don't want that to happen. Maybe if you've got an entire shift that is being shut down for maintenance, maybe if you've got 2 lines, you can do maintenance on one line and you can still keep production going on the other while you're doing it on the opposite, so that you have continuous production going on, although reduced production, but continuous production. They are going to be very concerned about the effective capacity. And oftentimes new equipment will have higher effective capacity because the maintenance requirements are smaller initially. And you would adjust these maintenance the effective capacity sometimes annually or at a programmed time based upon actual data. So if we're going through and we plan for the expected capacity to be 175,000 rolls, but in reality we were only getting 160, that loss of those 15,000 units has to be caused by something, but it's a reduction in your capacity overall. And sometimes you can't fix it. Sometimes it's just older machines require more maintenance, more frequent maintenance, and you have more breakdowns during production. New machines, that 130 might represent 90% of the actual capacity of that machine. And so your design capacity is based on a per machine capability, per line capability. So if I have one line that can do 175,000 rolls and the other line can do 130, you can combine those two. But it's based upon each line, and there's a variable in there that has to get contracted or expanded based upon what the actual throughput that's available to you. So in complex production lines where you have multiple machines in line with one another, so I could have a production line that's going through, but you might have a component of that production line that's capable of doing 250,000 rolls per hour. Let's say that's your dough making machine at this point, but your ovens can only handle 130 per hour. So the limiting factor is the smallest element on that production line, or the smallest throughput that's available on that production line. So you would say, okay, it's the limiting factor. It's like critical path in project planning. Whatever's in this case, whatever reduces you, constrains you, becomes the limiting factor of that production line. Now, if you come back and get an oven that can do 200,000 rolls as your upgrade, you're trying to justify that to maintenance or to management, then boom, you can go do it. You can get the whole line up to 200,000. Rarely do companies replace or put in new production lines all the way through the plant. They're generally plugging in and out elements on complex production. So, in this case, you might have a large mixer and you might have large containers, and how much can they hold and how quickly can they mix the batter and the dough for going into the rolls, and then you've got something that's flattening it out, automated cutting, and then running into the oven process. All of those machine processes then become potential limiting factors, because if any one of those breaks in the process, the entire line stops. It's not like you can skip one of those processes, which means you don't meet customer demand that day. Because if you're selling bread, bread is only available for just a few days, fresh to your customers. And if you become an unreliable supplier, grocery stores aren't going to keep you, and your customers are going to start drifting away. Have a very negative impact on the business. So the more throughput in production you have, the more profitable the business becomes. But you don't want to overspend. In Management 408, there's a simulation they run that if your utilization is too low, in other words, you overestimated the capacity you need, you actually get penalized for that. I worked for a company that based our bonuses on the profitability of the company, several factors related to profitability. Utilization was one of those. And so they calculated utilization. They used a different way to do this. But they took all the dollars they had invested in the plant, and if we and then a 5% return, because that's what they could get at the bank at the time. So they've invested, I don't know, $30 million in a 5% return. That's the amount of money they were expecting us minimally to generate. Anything above that, they considered that as profit sharing to us. And so that became very important to us. That has to do with the efficiency numbers, and all of that plays into it. So utilization becomes critical. You don't want capacity that's not being used. You want your plant properly sized. And that seems pretty obvious, but you'd be shocked at the number of companies that misinvest because they haven't gone through or have extravagant capability or thought they would have this need and really didn't. This happens in startup. So if you were a toy manufacturer and you're doing a small number and you're a startup firm on this, and let's say you were selling out through Etsy, you don't need to have a 500-gallon mixer of plasticizer and plastics to put into the molds that you're doing. You can buy it, you can invest that money, but it's a waste of money when you're going to be doing most of your work on the kitchen table or in your garage. You move to the garage and you can start upscaling. So the idea here is to appropriately size your production capacity and your measurements for that, your efficiency, your utilization, your actual output, your effective capacity. You know, you're going through this, and if you're only running one shift, your effective capacity in this case is cut by 2/3. Might not be quite 2/3 because you can move maintenance and all off into the next shift on that in an empty shift. But you have that as a capacity and said, okay, well, when COVID's over, we're going to crank up a second line because we're expecting production to go back up. You know, if you got extraneous situations going on, it gives you some flexibility. COVID also created hardships for companies that had high demand for their products during COVID. There are actually companies who are doing very well because of it, because our buying habits have changed, our needs, our wants, our desires, which is marketing, have changed. And we need to be able to address that in production. Stop share. Okay, any questions about that? I'm going to post this video up in just a couple minutes. The video from Wednesday is posted. I will be back in the classroom on Monday. And you've got your homework you're working on for critical path. Continue doing that. There won't be any homework related to this until next week. I have one more lecture we have to do. You will see all of this. You will see all of this. I'll say it one more time. You will see all of these calculations on the final. You'll have a giant problem and you have to apply it to. And there will be only like 2 or 3 problems on the final. But you'll have multiple parts you got to work through.
I do have a question about that last problem you had on the board.
Mhm.
Actually, I was sitting there as I was listening to you talk. I was trying to figure out some of these ratios, but I was trying to get, when you look back at it, I mean, it gives you that new effective capacity for the new line and all that. Were we supposed to be able to figure out the answers that were given down at the bottom from those numbers it gave us?
Yeah.
That seems pretty difficult. Those are like ratios of,
They don't give you everything because they don't tell you what the new design capacity is.
yeah,
You need one more piece of information to make all.
okay, great. Because that's what I was trying to figure out using like percentages and ratios, and I was like, this is not, I don't think this is right.
You're missing
Okay.
one piece of information on it.
Okay,
The answers to this problem are all in the slides that are on the website on Canvas for this week. So you can download those. You're responsible for this chapter. Next week we're going to be going over locations, location selection for production. So while those might have a question on a test or quiz, they're not, those chapters won't show up on the final. Doing these types of calculations are critical to what you can do, and you will see these on the final. Any other questions? Okay, go ahead.
What would that PowerPoint be under? Because I see yours, I think, was like the 12th one. I don't know what that translates exactly. I'm looking at chapter 7.
I renamed it. It's under, that's the, let's go here, I'll pull it up. Oh, I gotta get to the website here. Which one is that on? I got too many browser windows open. It might be this browser. There we go. So, I just uploaded the video, so I'm okay. Go back one more. Oh, yeah, I need to pull it up. Hang on a second. It's in week 8 right now. It's actually available to you. I just moved it into week 6. Yeah, into week 6. So it's chapter 7. Difference of additions here, guys, is all examples as we're going through. And I will, to be safe on this, I think I'm going to push up the, yeah, the examples are not going to be the same. Okay, I will push up the one I'm using for the class today. Give me just a minute and I'll upload it. So I'm gonna move that one back to 7, 8. Okay, and so I'm going to, I'll go ahead and do that in just a minute. And guys, go through and look at the slides, review them, review that problem and definitions in this, and just practice solving this problem by using unit analysis, not by the way they try to solve it. Judge, they're saying, oh, you need to take this, this, and this. It's not obvious at all. And by using unit analysis, you have a path forward with it. Any questions? I'm available by telephone today if you need me. You all have my number. If we need to do another Zoom meeting, I can do that with you too. Okay? All right, guys. Have a great weekend, and I will see you guys on Monday, those who are going to be in class.